Hey there guys, welcome to the video. My name is Pushpinder Gill, and in this video we're going to be talking about correlation, right? And this is the second video on correlation, and in this we're going to be talking about a mathematical approach towards correlation. Well, I'm not going to abruptly give you the formula. We're going to actually derive the formula and we're going to understand, why this formula comes about. So let's go ahead and get started. So if you watched the previous video, in that video you must have understood that we draw a scatter plot for our data set here. So we have two variables x and y, and we have some values for x and y, right? So let's suppose these are the values. And then what we do is, so this is x and this is y. We find the mean of x and we kind of say this denotes the mean of x. We find the mean of y and let's suppose we denote this as mean of y. We said this is the first quadrant, the second quadrant, the third quadrant and the fourth quadrant. We said that if something lies in first, if all the points lie in the first and the third quadrant, then we have positively correlation. If all the points lie in second and the fourth quadrant, that means they are negatively correlated, right? And if all the points are evenly scattered in all the four quadrants, that means we can say that there is no correlation at all. Now this approach is a very primitive approach. This is where we've evolved from. However, it's not accurate. When I say it's not accurate, I mean to say that it's not complete. So if you have data set with thousands and tens of thousands of rows and columns, and you really need a kind of a measure, a strength of correlation, then this method will not give you the strength of correlation. Well, we need some mathematical approach for that. Now if we need a mathematical approach for that, right, let's suppose if we pick up any point, let's suppose we pick up this point. This is point A. This point has x value x and y value as y. Now how do we mathematically define the correlation? Now understand here, this distance is going to be equal to y minus y bar, right? And this distance is going to be equal to x minus x bar, right? Because this is x and this is x bar, right? So this distance is going to be x minus x bar, and this is y and this is y bar, so this distance is going to be y minus y bar. Now observe here, the product x minus x bar times y minus y bar is going to be positive here, because x minus x bar is positive, because as you can see here, x is greater than x bar in this quadrant, in the first quadrant, and y is greater than y bar. So that means this is going to be positive and this is going to be positive. If I talk about, so this is the first quadrant. If I talk about the second quadrant, let's suppose this quadrant here x minus x bar is actually going to be, as you can see that x is going to be lesser than x bar, this is going to be negative, and y minus y bar is actually going to be positive. Similarly, because y is going to be greater than y bar here, this is y bar and y is going to be here. In this case, in the third quadrant, x minus x bar is going to be negative again, but y minus y bar will also be negative, because here x is less than y and x is less than x bar and y is less than y bar. Here x minus x bar is going to be positive, but y minus y bar is going to be negative, right? So if you observe here that the product x minus x bar times y minus y bar is going to be positive if all the points are in the first and the third quadrant. As you can see, negative into negative will give you positive, and the product x minus x bar times y minus y bar is going to be negative if all the points are in second and fourth quadrant. And if you observe here, we kind of defined, if all the points lie in the first and the third quadrant, then we're going to have a positive correlation, and if all the points lie in second and the fourth quadrant, we're going to have a negative correlation. Which means if I find the sum of x minus x bar into y minus y bar for all the points, all these points, let's suppose we have something which is positively correlated, so all the points are going to be lying here. So if I find the sum of all the points, I'm going to get a positive value, which means since I'm going to get a positive value, that means this will tell me that x and y are positively correlated. And if I get a negative value, that means this product will tell me that x and y are negatively correlated. So which is why we define this product. We said this product, let's suppose this is s of xy, which is actually equal to, so s of xy is actually equal to summation of x minus x bar times y minus y bar. So this is the product which actually tells us that whether something is positively correlated, whether two variables are positively correlated or they are negatively correlated. Well, there's some other thing as well which also determines the correlation, the strength of the correlation, and that is n, which is the number of terms. Now, as you observe, if there are only the lesser the number of terms, the more strength a correlation has. So the lesser the number of terms, the more strength the correlation is going to have. So let's suppose if you have just 2 points. So on this graph, if you have just this point and this point, then you're going to have a perfectly positive correlation, right? Or let's suppose you have 2 points like this, you're going to have a perfectly negative correlation. It's going to be a straight line, right? But if your number of points increase, when your number of points increase, what happens? It kind of dilutes your correlation, right? So when your number of points increase, it kind of dilutes your correlation, which means you can say that the number of points is kind of inversely proportional to your to your strength of correlation, right? So to your strength of correlation. So that means what we're going to do is we're going to define something now which is known as the covariance of two variables. So covariance of x and y is something which can be defined as this product over here, that is sxy divided by the number of terms, right? So covariance is something which is defined as covariance y divided by the number of terms, because number of terms is kind of inversely proportional to your correlation. As your number of terms increase, your covariance is actually going to reduce, right? So it's that's why. And this product is something that that tells you the sign of the correlation. It tells you whether something is positively correlated or something is negatively correlated. So that means from here you're going to get the covariance of two variables x and y to be equal to summation of x minus x bar into y minus y bar divided by the number of terms. So this is the covariance between two variables x and y. It tells us, so what is the function of covariance? What is the function of covariance? What does it tells us, right? It tells us the strength of correlation. It tells us the strength of correlation between two variables, right? So that's what it tells. So if I say that covariance of x and y is greater than 0, this is going to be greater than 0 if this actually, so this is nothing but sxy over number of terms, is if sxy is greater than 0, right? That means all the points are lying in the first and the third quadrant. That means the covariance is greater than 0. So higher the covariance, the higher the positive correlation between two variables is there. Similarly, if covariance is x and y is less than 0, that is only possible if s of xy is less than 0. That means you have something negative correlation between two variables. That means if x increases, y is going to decrease, and if x decreases, y is going to increase. Here, if x increases, y is going to increase, and x decreases, y is going to decrease. And similarly, if covariance of x and y is actually equal to 0, that is only possible if s of xy is equal to 0. Now, when will s of xy would be equal to 0? That is when you have no correlation. Now I'm going to teach, show a little, kind of a relationship here. Now when you have no correlation, as I said, when you have no correlation, all the points are evenly distributed in all the four quadrants. So if all the points are evenly distributed in all the four quadrants, that means if I, let's say, this point, this point, this point, and this point. So let's suppose this point are evenly distributed in all the four quadrants, then this x difference is going to cancel out this x difference. This y difference is going to cancel out this y difference. Similarly, this y difference is going to cancel out this y difference, and this x difference is going to cancel out this x difference. Similarly, the value of this term is always going to be 0 when you have no correlation between the variables, right? So when there is no correlation, that is only possible if f of s of xy is equal to 0. That means there is no correlation at all. That means you cannot find any correlation between the variables. Fine. So I suppose you're understanding this point over here, guys. Now what you can do is you can actually calculate the value of Sxy, which is actually equal to summation of x minus x bar into y minus y bar in some other way as well, right? So which actually sometimes helps you in an easy formulation of the answer. So let me show you how to do that. Now if I kind of open this up, so this is going to be equal to summation of x into y, which is going to be xy, into x into y bar, which is going to be minus xy bar, x bar into this, which is going to be minus x bar into y, and this into this is going to be positive x bar and y bar. So what I've just done is I've just opened this bracket up, and this is what I got. Now from here, summation of xy, so this is the whole summation. So I'm going to give the summation to this, I'm going to give the summation to all of this. So it's going to be negative of summation of xy bar minus plus x bar y minus x bar y bar. So what I've done is I've just opened this bracket up and given the summation to all, took care of the negative signs, and that's what I've done till now. Now what I'm going to do now here is I'm going to say summation of xy minus, now I'm going to give individual summations to everyone. So this is actually like this. So I'm going to give individual summations to everyone. So this is going to be summation of x into y bar plus summation of x bar into y minus summation of x bar into y bar, right? So this is what I have, and now what I'm going to do is it's going to be summation of xy minus, now as you know, y bar, x bar, which are the mean values, they are constants, so you can't have summations of constants, so constants are going to come in the front. So I'm going to have y bar into summation of x plus x bar into summation of y minus x bar y bar into summation of 1. So here if I kind of see this, so this is going to be equal to so that is what is going to be there. So this is going to be equal to y bar into summation of x plus x bar into summation of y minus x bar y bar. Now what is summation of 1? So those are going to be n terms, right? Because 1 from I is equal to 1 all the way till n, that is going to be total of n terms, so n is going to be here. Now next step, which is actually very crucial, what I'm going to do is I'm going to take out 1 by n common. So if I take 1 by n common, I'll have to multiply n with this, multiply n with this, and multiply n with this. So I'll be left with n into y bar into summation of x plus n into x bar into summation of y minus x bar into n times y bar into n, because I'm going to get two n's here, so I'm going to multiply each term by n. Now this is what I have here. Now from here, if I just change the color, now from here, as you know, that x bar is equal to summation of x over number of terms, which means summation of x is equal to n into x bar. Similarly, summation of y is equal to n into y bar. Now if I substitute that here, I'm going to get summation of xy minus 1 over n times, so this term is actually going to be equal to summation of y times summation of x plus this term over here is going to be equal to summation of this term is going to be summation of x times summation of y minus this term is going to be summation of x times this term is going to be summation of y. And as you know, this and this will cancel out with each other, so I'll have the value of Sxy to be equal to summation of xy minus summation of x into summation of y over number of terms. So you can say S of xy is equal to summation of x minus x bar times y minus y bar, or you can even also say that summation Sxy is equal to summation of xy minus summation of x times summation of y over the number of terms. So these are the two ways you can calculate the value of Sxy, and covariance of xy is just going to be equal to Sxy over the number of terms. Fine. So suppose you're able to understand this point over here. Now let's go ahead and do a question. So let's suppose we have x values and we have y values, right? So I'm just going to draw it in terms of this. So let's suppose we have x values and we have y values. Let's suppose x values are 31.1, 33.3, 36.0, sorry, 30.0 and 31.5, then 35.0 and 30.2. Let's suppose these are our x values and these are our y values, that is 36, 37, 38, 38 and 40 and 40. Now what we have to do is we have to find the value of SXY here. So that is, we have to find the value of SXY, or let's suppose even we have to find the covariance. So first we'll have to find the value of SXY. So if we want to find the value of SXY, what will I do is, I will actually use the second formula here, which is SXY is equal to summation of XY minus summation of X into summation of Y over the number of terms. So the summation of X is just going to be equal to the sum of these values. So if I add all these values up, I'll get, if you just add all these values up, I'll get 191.1. And summation of Y is just going to be equal to the sum of these values. If I add all these values up, it's going to be 229. So if I just add all these values up, it's going to be 229. And what do I have to do is, I have to find now what is summation of X, Y. That is what I have to find. So what I'll do is, I'll find XY here. So 31.1 times this is going to be 1119.6. So I'm just going to use my calculator here. So this into this is going to be this. This into this is going to be this. This into this is going to be this. It's going to be this. And this is going to be equal to, so this is 35.0. This is 30.2. This is going to be this. So summation of XY, if I add all these values up, that's actually going to give me 7296.7. So these are just calculations. I'm gonna skip the calculations part so that we can hit the real point over here. So if I want to find the value of SXY, that is actually going to be equal to summation of XY, which is this, that is 7296.7 minus summation of X into summation of Y, which is 191.1 times 229 divided by the number of terms. So if I calculate this value, the value of SXY is actually going to be equal to 3.05, and the covariance of X and Y is actually going to be equal to the summation of SXY divided by the number of terms. That means there are 6 terms, 1, 2, 3, 4, 5, 6. So this is actually going to be my covariance. As you can see, there is a positive correlation. That means if the value of X is increasing, the value of Y is also increasing. So that is the covariance of X and Y. So thank you very much for watching this video, guys. I suppose you understood this part. In the next video, we're going to be talking about the coefficient of correlation, right? Wherein we would be defining, here we define the strength of the covariance of the correlation between two variables. There we're going to be, talking more about, the coefficient of correlation, right? So, I'll leave that to that video only. So thank you very much for watching, guys, for this video, and I'll see you in the next.